Recording. I have audio. Okay, I'm going to go ahead and begin. It is Thursday evening. Let me get out of these headphones. It is Thursday evening. It is February 8th, 2018. This is the scheduled class meeting. Good evening. Scheduled class meeting for ITSC 2309 at Collin College Computer Lab. And soon have a few more students, I think. Let's see. We'll begin tonight. We are going to be beginning Module 6, I believe. Let me just double check. Yes, Module 6. And in Module 6, under the student resources, there are, Module 6, it's based into two pieces, Part 1 and Part 2. Under the student resources, I'm going to be making some changes to those slides, so pay particular attention to them. Some of the slides are just wrong. Sorry about that. We're going to be talking about joining tables tonight. Joining tables is where we follow the link, the foreign key, up to its primary key. And that said, let's go ahead and begin. I am in my SQL here. Notice that I say use SW Smith. Whenever I say that, I mean for you to be using your own database, not the one that is AP_DB. So whenever we're just creating tables, we're going to use our database. So change this to your own personal database. That's the one with your name _DB. When I use APDB, that means the accounts payable database, the one that we're using. So I'm creating a couple of tables. I'm creating a table called, table called parents. I guess I should have made this one plural. If parents was plural, I should have said children, but whatever. So I'd have to drop the child table first, then drop the parent table. Create the parent table first. Now notice that the parent table doesn't have much in it. It's just a parent ID, a primary key, and a parent name. Assumably there would be more stuff than that, but this will demonstrate what we want to demonstrate. So it's just a very simple little table. And finally, the child table has a child ID, primary key, a child name, and a parent ID, which is a foreign key into the parent table. Just about as straightforward as we can get. By the way, I have sent you this file in an announcement. So if you look at your Canvas announcements, you can download this file easily and follow along there. So it's got a foreign key. I may as well mention right now that sometimes our, excuse me, our PowerPoint slides will do something like this. CID char4 space primary key. Yes, it works. I won't like it though. Why won't I like it? We're not naming the constraint. So this will work. These two forms of the same statement will create, both of them will create a table. However, the second one, the one that's commented out, will not have named constraints. So there, notice that the primary key is just, okay, it's the primary key. That constraint, primary key, does not have a name. Similarly, the foreign key is created, and in many platforms, you can just say PID references parents. All you need is those three words. That is bad form. Okay. You don't even have to specify the type. It picks up the type from the parent. Don't use this. See that? Don't do this. That means don't do that. Okay, let's move on. I'm inserting some things into parents. Notice I'm inserting into parents 1, 2, and 3 with some names there. Into the child, I'm inserting 9 and 8 and 7 coming down so that we can tell them apart easily. Okay. To which parent does child number 9 belong? To Bill. I don't know why I named that child Bob Jr. I guess I should have named him Bill Jr., huh? Whatever. His name is Bob Jr. I'll scroll up. And he belongs to the parent with ID 2. Happens to be Bill. Notice that Ted, child number 8, belongs also to Bill. Child number 7, which is Sally, belongs to Betty. 3. You see those relationships? Yes, you do, or no, you don't. Do something to indicate either you do or you do not understand what I'm doing. Okay? All right. What about the parent number 1 named Bob? Bob doesn't have any children. That's okay. Doesn't hurt our schema any. We don't have any orphans. No children with null parents. Although we did not put that on as a constraint, we just don't have any. Okay. Joining tables. The old syntax. This is the old syntax. What am I selecting from this? I am selecting, well, let's go to the from line first. I'm going to go to the from line first. Notice I have 2 tables in my from line. Are you with me that far? 2 tables. Parents, child. They're separated by a comma. I am renaming them. Parents as P. Child as C. I'm renaming the tables. That's important. That's going to save me a lot of typing. I hate typing. Okay. Select P.PID. What? The parent.PID as parent PK. CID as child PK, and child.PID as parent foreign key. Now, notice that I have a P underscore ID in both tables. Let's scroll back up to see them. Both tables contain a field named PID. I said to keep it that way. I said that's good. I like it that way. Why? Because that foreign key takes the name of the primary key and keeps that name. I think that is good practice. It is not required that they have the same name. The foreign key does not have to have the same name as the primary key, but in my opinion, it should have the same name. Does it make sense? It's taking me to another table. When I get down here into a select statement that has 2 tables in it, I have 2 fields. I have the parent PID and the child PID that have the same name. Whenever I talk about the P underscore ID, the primary key of the parent, I have to specify which table I'm talking about because it is the same name in both tables. The fact that I think it's good to have it the same name in both tables is kind of coming back on me here because now I have to specify which one I want. Here, I want the parent, the primary key of the parent, and here, I want the foreign key of the child. Now, when I'm talking about the child ID, there's only one of those. I don't have to specify which table for that one. But there's only one. If I put C.CID, it would be fine. It wouldn't hurt anything, but I don't have to. Okay. Now, go ahead.
You said when it's reading that line 52 to 54, it reads the from before it reads the select.
That is true, yes. The question was which happens first, the from or the select. Yes, the from happens first. And then the where would happen after that, and then the what, the select what. There isn't a where, so it's just everything in there. Okay? So I'm going to put both of those tables together. Now the question is, how do they go together? So let's run this query and look at the output of it. I'm going to go ahead and run it. Execute. Okay, whenever this happens, I haven't ever executed it. I've opened it without telling it which table. Go up there and say which one to use. Parents. P-A-R-E-N-T-S, P-A-R-E-N-T-S. Let's go ahead and create, maybe I haven't created them on this one yet. There we go. Now here's the data, here are the data, and I'm going to switch over to Microsoft Word where I have pasted it over there. If you can look at these data here, and we can see them a little bit better here. This is the primary key of the parent. This is the foreign key of the parent in child, okay? Are you with me? What did I say to select? I said select the parent, P.PID. I said to select the child, PID. Don't worry about the child primary key right now. The child ID, I don't care about that. Let's just look at those two parent keys. One of them is the primary key. One of them is a foreign key. Now let's go back and look at what we got. Notice that I got 1, 2, 3, parent foreign key 3, 3, 3. I got again 1, 2, 3, 2, 2, 2. 1, 2, 3. In short, I got them lined up any possible way I could. I should have gotten 1, 1, 1, but I don't have any ones in there. Notice that the child is 777 888 999. Okay, so basically I got those three. I've got 3 fields in one table and 3 fields in the other table, and it put them together any possible way that they could be put together. Do you see that? That the parent and the child, the rows in the parent, are joined with the rows in the child every possible combination it can make. If I have 3 in one table and 3 in the other table, how many rows will I have in the output? 3 times 3, 9. If I have 100 rows in one table and 100 rows in the other table, how many rows will I have in the output? 100 times 100, 10,000. Okay, if I have 4 rows in one table and 4 rows in the other table, and I'm going to put them together every possible way. So I start with 1. I'm going to have 1A, 1B, 1C, 1D. 2A, 2B, 2C, 2D, 3A, 3B, 3C, 3D, 4A, 4, and so on. I'll have 16 rows. Yes, because that's the logic behind it. When you just include 2 tables like that with a comma between them, you get every possible combination. But we don't want every possible combination. Which ones do we want? Look at the ones that are highlighted in yellow up there. For example, this one that I've highlighted. What is it about that row that makes it the one of them that we want to look at? Why are we not interested in either of these, but we are interested in this one? And hint, it's not because it's highlighted in yellow. The parent key matches the foreign key. Notice also that the parent key matches the foreign key. The parent key matches the foreign key. Those are the ones we're interested in. We don't care about the others. They're not part of what we want. Sometimes we actually will do, that's what we call a Cartesian join or Cartesian product. It's every possible way we can put the table together, and it makes it big. Okay, let's go back then to our join. Since this isn't what we want, there's more than what we want. Instead of this, whenever my rows scroll off to the right side of the screen, I just simply break them back. I do a carriage return and tab them a little bit. It's okay. It is the same one, except I have added a where clause, where the parent ID equals the child parent ID. Now, if I were to run this, let's go over here. Let's see, 1, 2, 3, 4, 5. Let's see what happens if I text to table. How do you do this? Let's see, width, autofit. There. Okay, now notice that in this case, I got exactly that material, only that where the parent primary key is equal to the foreign key in the child table. Okay, so I can see that the parent name Betty is associated with the child named Sally. I see the parent name Bill is associated with the child named Ted. The parent name Bill is associated with the child named Bob Jr. I guess I meant to say Bill Jr. I don't know. Whatever, that's the name of the child. Okay, the reason, because the foreign key agrees with the primary key. Questions? Have one for you then. What happened to the parent with parent ID 1? I guess that was Bob. What happened to Bob? Where's Bob? Comments? People online may comment. I have my headset on, sort of.
There wasn't a child equal to.
Okay. Go ahead.
There wasn't a child that corresponded to the parent, and therefore it did not pull that row.
Okay. Online student answers. There was not a child. The parent did not participate in the relationship. Therefore, the parent does not appear. This is a property of this type of a join. If the parent does not participate in the relationship, the parent will not be present in the join. Childless parents will not be present in the table join. Boy, you better believe that's a test question. Now, this is known as the inner join. And it looks like this. Now, I'm going to go back to the screen. Okay. Line 58 through 61 is the old syntax of the inner join. It still works today. It works all the time. You will still see old-time SQL writers are demanding to write it like this. So they put both tables in there and link them in the where clause. The as is not required by SQL, but it is required by your instructor. Okay, you can drop it. It is possible. Later, after you get out of this class, you can say P_PID space parent PK, comma, drop the AS. But don't do it in here. Okay, I'm now going to discuss what happened to the one. Okay, we talked about that. The new syntax. Notice that everything that's in the old syntax is in the new syntax. Nothing special. I call it new. It comes from about 1992 or so. That's before a lot of you were born. I think 92, 93, I forget when that convention was, where they changed, and I'm going to tell you why they changed. There was a reason. But notice that the select line is exactly the same. And similarly, when I scroll off, I break the line and tab it over. Notice that with select line is exactly the same. Notice that the from, instead of just saying parents as P, comma, child as C, we say parents as P, inner join. Okay, I'm going to stop right now. If you go out online, if you even go to the overheads, whoever it was that wrote these slides for this class did not take a lot of trouble with writing them. He probably had some student writing them. It probably wasn't the same person as the author of the textbook. The slides and many places on the internet and even many textbooks will drop the word inner. Pause there for a minute. They will drop the word enter, and it will look like this. From parents, join child. Do not do that. I want to see the word enter. If you're doing an inner join, I want to see inner join. That's all you know how to do right now. You're going to learn another one next class meeting. Right now, the only one you know is inner join. That's fine. I want you to write inner join. Don't just write join. Okay, the full syntax is inner join. SQL Server will allow you just to say join, and if you just say join, it has to be an inner join. I agree. Many platforms will let you get away with that. I won't, not in the class. I might write it that way outside of class. I won't write it that way here. Similarly, you can drop the AS many times. I say, if you write it this way, what happens? You lose points. You don't want to do that. I'm telling everybody right now, I'm going to tell everybody in the other class, don't just say join, say inner join, use the full syntax. Will be important to do that on the test. The instructions will say use the full syntax. I mean, write inner join, not just, even though that will work. Won't work for me. Okay. So this is the same. Notice that everything that is here, everything that was in the old syntax, from parents, comma, child, where, has been matriculated down into the new syntax, from parents as P, inner join, child as C, on. If you have a where clause, it comes afterwards. So in the old syntax, the linking of the two tables was done in the where clause. In the new syntax, the linking of the two tables is done in the from clause, in the on part of it. Everything in one of them is also in the other one. What's up? Question? I'm going to pause for a minute for questions. If online people have a question, I have a headset around my neck, I can hear you. It's been my experience that once you present something, you have to wait almost a painfully long time for questions. Teachers love to hear themselves talk. Let's do an example. Example. List all vendor names, invoice ID pairs. Vendor name comes from the vendors table. Invoice ID is in the invoices table. They're joined on vendor ID, which appears in both tables. Vendor ID is the primary key of the vendors table and the foreign key of the invoices table. Am I making any sense at all? I don't see anybody saying yes, but I don't see anybody saying no either. Okay, I'm going to join the two tables and show the pairs. Now I have to say, because I'm switching databases now, I have to say use AP_DB. If I don't, it's going to say Don't know what you're talking about, vendors table. We don't have a vendors table because the last thing I used was my database, SW_Smith_DB. I'm switching databases. That's okay. So I switch. Select what? Well, select what it told me to select. From vendors, I always rename them to something shorter, as the. I hate typing because I'm going to have to type. Inner join, invoices as I. Do not say join, say inner join. On, here's where I would have to type it. I would have to type vendors.vendorID is equal to invoices.vendorID, and I put in an order by in there, order by invoice ID. Okay. The only place I had to qualify the table was in the actual join field, the on. If I execute this, notice that I get 119 rows, and notice that I get one field, one row in the output for each invoice ID. I believe I have 119 invoice IDs. I don't think I have any orphan invoice IDs. I might have one. I might have put one in there. I don't remember exactly. It'll become obvious later if I did, because I think I did. I'll ask you to go find it. For right now, remember, an inner join does not show childless parents. Do I have any parents? Do I have any vendors who have no invoices? Yes, I do. For example, the United States Postal Service is in the vendors table, yet you do not see it in the output of this query. I'm going to let you run the query yourself. And you can look in there and see there are probably 65 or 70 vendors that do not have any invoices. There's quite a few of them. I will let you. We do not see, they do not appear in the output. Why? Because that's a property of the inner join. When you use an inner join, you do not see childless parents and you do not see orphans. Only see the relationship. Inner join shows you the relationship. Questions? Okay. That showed me all of the invoice IDs, I believe. I might have one invoice ID in there that is not shown. Leave that to you. I don't know how these are different. Oh, this one I'm ordering by vendor name. You can execute this one if you want to. This one makes it easier to find. If you execute this one, the order by is different on the one from line 96 to 99. If you execute it, you should see a little bit better that not all of the vendor names are represented. In fact, quite a few of them aren't. It won't take you long to find it if they're ordered by the vendor name. Questions? You guys are awfully quiet tonight. 634. Don't let me run off and leave you. If you have a question, now is the time to ask it. Go ahead, please. Let me see if I can get this question. One more time, please, Nina. Show the relationship. The relationship is on line 98. The vendor ID from the vendors table equals the vendor ID from the invoices table. That is the relationship. That's what causes the relationship. So the vendors is the parent table. Vendors is parent. Invoices is the child. So a vendor can have 0 or more invoices. And they get the invoices. If I were to go look, if I go look at the invoices table and look at its columns, and I'm sorry it's fairly small here, but I see the vendor ID is a foreign key. It says FK right there. It's a foreign key. The primary key is the invoice ID. I'm not as concerned about that because I'm concerned here in the relationship with where the foreign key is equal to the primary key in the vendors table. This is what causes the relationship when this foreign key is equal to the primary key. So when this is true, and think of that as a where clause, where the primary key in the parent table is equal to the child key in the foreign key in the child table, then that's one that I want in the output, or it's one that I would consider for the output, given that it now I can have a where clause. So it is possible I can have a where. I don't have to have the where here, where in the old syntax, back in the old days, I had to have the where to join the tables. No longer do I have to do that, although the old syntax still works just fine. I like the old syntax. I like to start with the old syntax because it gives me a good way to lead into it. I think it's more intuitive. I don't know that there are any pitfalls of the old syntax. Well, I'll talk about why we changed it. We haven't gotten there yet. Next class period, I think we will get there, and we'll see that there were some ambiguities in it when we get to the other kind. We have an inner join. It's what we're looking at today. What's the opposite of inner? Outer. So we're going to have an outer join. And when we got to the outer join, it wasn't real clear what the correct syntax was. So they standardized it. And inner join became INNER join. Outer join became outer join. And I'll show you where that where it wasn't clear what you were talking about in the old syntax. And so different databases started doing it different ways. And so they finally said, okay, stop, everybody's gonna do it the same way. But the inner join wasn't a problem. So the inner join, the old syntax still works. I think I give one assignment where I say, do it by the old syntax, because there's lots of people out there that still write it that way. And they will write the join clause. They'll join the tables like this, and instead of saying on, they'll put the join condition in the where clause, and they get exactly the same thing, and it always works. This is the preferred syntax, unless on a test I will say use the new syntax. Questions? Okay. What time are we? 6:40. Textbook example, page 134 and 135. Find pairs of, I think names means vendor names. Find pairs of vendor names that share a common city. Now, this is an example of a table joined with itself. You sometimes join tables with themselves. I usually leave this one till a little bit later, but our textbook brings it up pretty early, so therefore I bring it up when it comes around in the textbook. I'm following the text pretty carefully at this point. The join a table with itself. I want vendor names where they share common cities. The city of the first one is equal to the city of the second one. City name. Now, I'm going to go ahead and kind of punt the idea that San Diego, California and San Diego, Texas are two different cities, right? But I'm not going to worry about that. I'm just going to say if they're equal, because we don't have any of that problem. But I suppose it would have to be city and state. We'll just say city. Now, look at some of my issues here. This one will have a lot of redundancy, meaning it's going to say the same thing over and over. If Joe lives in the same city as Bob, then Bob will also live in the same city as Joe. So I'm going to have Joe, Bob, and then Bob and Joe. Okay. Well, that's not as big of a problem as, what about, what's this, Tom? Okay, Tom. Tom lives in the same city as Tom. Therefore, I'm going to get a pair, Tom, Tom, and Sam and Sam, Sally and Sally. So I'm going to get a lot of them, but logically, those are all valid pairs. Now, here we go. Let's look at it. I have, I'm going to go with the from line first. From vendors. In this case, I must rename the table. In order to do the inner join with itself, I must rename the table. Inner join vendors as V2. So I have V1, V2. They've been renamed. So select V1 vendor name as name 1, V2 vendor name as name 2, on v1.vendorcity is equal to v2.vendorcity. Now, when I execute this fun little program, I get 1,896 rows, and they keep going and going and going and going and going. Why? Well, First place, every place that V1 is equal to V2, I'm going to get Tom and Tom. And then V2 is going to be equal to V1. That's also Tom and Tom. I'll be able to tell them apart. So I have a lot of duplication. Bill lives in the same city as Bob. Bob lives in the same city as Bill. Charles lives in the same city as Bob. Charles lives in the same city as Bill. Tom lives in the same city as Bob. Tom lives in the same city as Bill. And it's just redundancy. It's redundantly redundant. Nina, do you know the word redundant? It means saying the same thing twice. Say it over and over. Okay. Now I can fix that fairly easily. On. If I put a where v1.vendor_name is less than v2.vendor_name, I'm only going to get one row. For Tom and Bob, I'll get Bob and Tom, but I will not get Tom and Bob because it will fail that where clause. Okay. I will also eliminate equals because I can't get Bob and Bob because they're not less than. It has to be less than. This one's going to reduce it quite a bit. What did I get? 887 rows. And this is a lot more manageable. Now, why did I get the 887 rows? I have more pairs than I have vendors, and the reason for this is because, well, let's assume that Al and Bob, Charles and Dale all live in the same city. I have Al and Bob, Al and Charles, Al and Dale, Bob and Charles, Bob and Dale, Charles and Dale. So I have 1, 2, 3, 4, 5, 6. I only had 4 vendors, but I have 6 possible combinations of them. Excuse me, permutations. Okay, so I have more. And since I have lots of duplicated cities, since I have some cities have lots of people, for example, like Fresno, California, has lots of duplicates in it. So that's going to give me a lot of different combinations there just from Fresno, California. So if I were to pull Fresno, California out of this, and I say, you know, where it's less than, and I don't want to see Fresno, California, please, because that's just going to give me too many. Now I'm down to a nice manageable number of rows that I can look at and see what's coming up. So I've just thrown out Fresno, California. Excuse me, because I have so many vendors in Fresno, California. Guess where our author lives? Fresno, California. How did you guys figure that out? Okay. Okay. I have another example coming up. Right now, we are coming up on the 6:50 mark. Pause here for a minute for questions. I'm going to do another example and some review. The inner join is the objective for tonight. I'm going to pause the recording, get a drink of water, visit the facilities. Oops. I've resumed recording, coming back from break now. I'm missing a couple of people, but let's talk about the more common example. The much more common, notice I've gone back to S.W. Smith now, so I'm creating this. The more common example where a table is joined with itself would be something like this. Employees. I have a table I'm calling employees. Now notice the way this table is set up. I have an employee ID, some other stuff, other fields, I mean, you know, department, phone number, all that jazz. And a supervisor, that's what I'm really interested in. So an employee and a supervisor. Now, as a supervisor and employee, yes, the supervisor will appear in the employees table. So notice the constraint, okay, foreign key, super, references the table. The table references itself. Now, many languages won't let you create the foreign key until later. I'll show you how to do it. What you can do is you can insert one row, one supervisor. This is the chairman of the board or something like that. This one record supervises him or herself. Who is the supervisor of employee number one? Employee number one. Nobody else will have that. Okay, so I insert him first. Now I can add a constraint. This is the way you add a constraint. I thought I'd mention this at this time. You can also disable a constraint, except for the primary key. You cannot disable the primary key. But a foreign key you can disable, and it will let you put in bogus foreign keys. Then you can re-enable it, and it won't check them. I will talk more about that later when we get to it. I just thought I'd mention it right now, because sometimes it's hard to get that first one in there. Now let's look at this one. The employee, primary ID 1A, answers to chairman of the board. 1B answers to the chairman of the board. 2A is supervised by 1A. 2B is supervised by 1A. 2C, 1A. 2D, 1B. 2E, 1B. 1B is right there. So it's this hierarchy of people. And assumably I would have others below them. Okay. Now, if I want to see that, if I want to see all of those relationships, select E1, EID, E2, the supervisor, from employees E1, inner join employees as E2, where the employee IDs are equal. It will almost always be where the primary keys are equal. But we saw the last example was where the cities were equal. The cities weren't a primary key. A join is almost always on primary keys. It doesn't make a whole lot of sense to join on something that's not, but we just saw an example where we wanted the cities, people who are pairs of people who lived in the same city. I don't know why we would want that. What would we ever do with that? I don't know. I guess we want them for some reason. No telling what people will want. So it can be, you can join on something that is not a primary key. It is almost never done. If I execute this, if I decide to execute this, I'm going to have to go up and start from the use, because I've got to create the table. And here I see my relationships. EID 1 is supervises him or herself. 1A is supervised by 1B is 1, and so on. And I just basically see those relationships given back to me. And I could get the employees' names if I had the names in there. I don't. Or I could find their departments if I had the departments in there, or their phone numbers or whatever. Yes.
Going back to line 154 or 164.
Lines 154 through 164.
So, I see on line 164, you said the foreign key eSuper is not null. You use the alter table to do that?
Well, I'm pointing out that sometimes it's tricky to get that first one in there. Sometimes with the foreign key, it will not let you put in the pair 1, 1. It won't let you put in a record that references itself. Now, SQL Server will, but others won't. Therefore, what you have to do is not put the foreign key on it at first. And go ahead and put that record in there, and then add the foreign key constraint. I'm adding a not null constraint, but the foreign key constraint is added the same. So probably alter to add constraint. It would look like that. I would add the foreign key constraint. Now, it's not going to have a problem with this row because 1 is in the table. But right when you put it in there, sometimes it will barf. The other option is just to leave null. I don't have a supervisor. Nah, nah. As opposed to I supervise myself. So if I put it in there, it's getting that first one in there that's the problem. We also sometimes call it, when we do it that way, we call that, sometimes we call it the parent of orphans, and we put a record in there that is the parent, is the final parent of everything. Just to get it started. And sometimes that's tricky. I didn't really want to get bogged down in that particular discussion right now today. But that first one can be tricky. So what I usually do is I don't put a constraint on it. I don't make it a foreign key. When I create the table, I don't make it a foreign key. It's just a field. And then I put in 1, 1. Okay, that's the first record that supervises him or herself. Then I add the foreign key constraint. So when employee 2 comes along, they can have 1 as their reference. But I can't have any other employees that supervise themselves, except for that first one. So everything ultimately goes back to that one in the chain of command. SQL Server doesn't have a problem with it. SQL Server will let you put in a record that references itself. Many of them will not. So it's kind of like I'm my own grandpa. Can I be my own parent? In SQL, some platforms you can and some you cannot. if you take that constraint off, then put yourself in as your own parent, and then add the constraint later, it will work. Okay. Let's try an example. By the way, I put out an announcement on number 5. The output I had on number 5 in the last assignment was wrong. Just look at the assignment. Number 1, we've already done it. By the way, explicit join is the new syntax. Implicit join is the old. So in our textbook, they called the new syntax the one that says inner join A, inner join B on primary key equals foreign key. That's explicit. From A comma B, where the primary key equals a foreign key, is the implicit join. I think I say that. So implicit join, the implicit join is described on 139. That is the old syntax. I ask you to do that one. Do it once, I think, is the only time. Vendors, chill accounts. Okay, let's look at number 5. Number 5, you must know that the invoice ID of the invoice line items table references the invoice ID of the invoices table. Also, it has a 2-field primary key. So, in number 5, I'm asking you to take something from the vendors table, vendor name, and I want you to take something from the invoices table, 2 things from the invoices table, and I want 3 things from the invoice line items table. How many tables will we have to have? 3 tables. Let's see if we can write that one. Let's go ahead and get that one started. And then you'll be that far ahead of the exercises, right? So I'm going to go ahead and pause the recording. Those of you who are online listening can go ahead and do that. We are on exercise number 5 in module 6, exercise 5, and we have pointed out that I'm going to have the vendors table, the invoices table, and the invoice line items table in the select statement. I'm going to have three. It's a 3-way join. So think of it as like hooking 3 freight cars together. I'm going to pause the recording, and I'm going to go around, and then I'm going to come back, and I will do that. So those of you who are following this will be further along. Pausing the recording now. Okay, I have put the from line up here. I'm just going to leave it up here for now, and I'm going to come back and talk about it in a few minutes. Let's see if this executes. Anytime you get an invalid object name on a table that you know exists, you probably haven't done a use. Let's see, SEQ num, what is that? Invoice sequence.
Use the AP database.
Yes, it's the AP database. Anytime we're talking about invoices and vendors, it's going to be the AP database. These guys all get renamed. So it does ask you to rename all of these, I think. And what's the where clause? Sort the result. I'll let you do the sorting. I'll let you rename them. There is not a where, so this is the end of it, except for you got some order bys to put in here. I think this will run. Vendors, okay, well, I thought I had taken care of that matter. And I get 116 rows. I think I said 118. Sometimes I change the tables up a little bit from semester to semester. So what did I say in I said it returns 118 rows. I'm getting 116. Don't worry about the difference. I suspect that what I did, I modified the data a little bit between them. 116 rows. So don't worry too much about 1 or 2 rows. Sometimes what I do is I go back in and modify the data such that it has some invalid rows in there for you to find later. Because all of the data were perfect data, and I said, wait a minute. When we're talking about having bad data, how do you find bad data if you don't have any bad data to find? So I put a few invalid invoices, in an invoice that belongs to an invalid vendor or something like that, or maybe an invoice with a null vendor or something. I don't know what I've got in there exactly. Okay, let's take a look at my solution. Are you guys still working on your solutions, or have you given up or gave up? Oh, don't be so quick. Well, let's take a look at it. Okay, there will be one of these on the test. Okay, it asks you to rename these fields, so there's going to be some as's in there, but that's pretty straightforward. That's easy. The tricky part of this one is the from line. Here's the from line. Okay, from vendors, inner join invoices. There's the on. Then this is inner joined with invoice line items, and I named that L. What joins the vendors and the invoices is vendor ID. What joins the invoices and invoice line items is the invoice ID. I tell you that in there. Learn to pick those things out by looking at the graphical layout of it. Take a look at it. Every one of them is, not everyone is a foreign key in our whole database. I will point it out when we come to some that aren't foreign key primary key. Go ahead. Okay. Now, other thing, it doesn't matter which order you do them in. There's 2 connections. You have to make the 2 connections. Had you put the invoices first joined to the invoice line items and then joined that to the vendors table, you would have accomplished exactly the same thing. Had you put the invoice line item, had you put the invoices first, joined it to the vendors table, and then joined that to the invoice line items, or almost in any order you want, so long as you're joining the vendors and the invoices in any order on the vendor ID. And you are joining the invoices and the invoice line items on the invoice ID. Now, mix and match those any way you like. Okay. I can think, let's see, 1, 2. I think there's 6 different ways to write it. Now, I usually start with the first one and come across from left to right. But there's no reason you couldn't start with the invoice line items and work through the invoices and end up at the vendors table. You'd get exactly the same output. Question. That's another property of the inner join. It's independent of order. Now, you can't join the invoices table directly to the invoice line items. Why? They don't share a primary and foreign key. You have to go through the invoices table. You have to have all three tables in the join, even if we're not taking anything from the invoices table. If I want to take something from the vendors table, pair it with something in the invoice line items, I have to have the invoices table in the join because I have to go through it. Okay. Let me give you another example. Okay. Ready for another example? How about this? Show me all of the vendor ID, invoice ID pairs. Vendor ID, invoice ID pairs. Think about that one for just a moment. Hint, it's tricky. I'm throwing you a curve here. Invoice ID, vendor ID pairs. What tables do we need in the select statement? Yes, if I want to show you vendor ID, invoice ID pairs, what tables do I need in the selects in the query? And then you're saying what now? Go ahead, please. I'm kind of expecting you to be wrong, so go ahead. Go ahead and do it and make my day. Don't be afraid to be wrong. It's okay. No, you don't need the invoice line items, clearly. What do you need? Vendors and invoices. Okay. Now, look carefully, please, at invoices. Don't you have all of the information I'm asking for in the invoices table? Answer is yes, you do. You only need one table to answer that question. Look at the pull up your invoices table over in your GUI there. Eric, right?
Yes.
Eric, I'm sorry, I'm trying to say your name, sir. Nick. Okay. Open your invoices table in your graphical user interface over there on the far left. Go to your databases. Yeah, no, open your databases. Open your, let me see if I can pull it up here. Look up here. View, okay. APDB, under tables, invoices. Do you see that we have the invoice ID and the vendor ID in that table? Now, if I had said vendor name, invoice ID, you don't have the vendor name in that table, so you'd have to go to the vendors table. But if I say I want vendor name, vendor ID, invoice ID, you can get all that from one table. That's a tricky point, and that will tend to bog down a database if you write queries and have extra tables in there. It won't be able to know that you want them all from that, hey, you can get everything you need from one table. It will go ahead and join the two tables at the cost of more work. Where if you took it, the human can realize, oh, I can get everything I need from one table, and should. That's just a little caveat. Don't put extra tables in a join if you can keep from it. Other things. It's about 7:30. Let me go back to the module. Modern syntax, self-join, multi-table joins. A parent has 0 or more children. A child has 0 or more toys. So you can have multiple tables. It's not unusual to see these relationships going down 7 or 8 deep. I think all we're going to do is about 4 deep, but enter join review. Questions? Let me hit this review right quick. No. Look at the review. If you go through the slides will just say table A, join table B. I want you to say inner join. Okay? Well, we'll end it there for tonight. For the purposes of this class, inner join following a foreign key primary key link. A table can be joined on something that is not a primary key, foreign key, but they almost never are. It does not make any sense to join a person's telephone number to another person's address. That just doesn't make any sense. Why? Because I'm looking for where the telephone number is equal to the address. I'm not going to get it. What sense does it make to join a person's first name to their last name? Well, I guess I'd find everybody who's had the same first name and the same last name. Where the first name was equal to the last name. Almost always be a primary key, foreign key relationship. Doesn't have to be. We saw that in the vendor city. It wasn't. Questions? Questions? Okay, I'm going to turn off the recording now, or pause the recording. I'm going to leave the audio on. So